What's going on, guys? In today's video I'm going to be covering a little bit more of an advanced tutorial. So I'm going to be talking about how to set up an analog to digital converter for the Raspberry Pi. So the things that you're going to need include a set of male to female jumper cables, breadboard, in this case it's a half-size breadboard, the MCP3008 analog to digital converter, and some flat breadboard jumper cables. They just make wiring a lot nicer. They're not really necessary. You can get away with regular jumper cables, but in this tutorial I'm going to be using them. Raspberry Pi, in this case the Raspberry Pi 3, and for testing purposes we are going to use a capacitive touch sensor, which is analog. So there are two ways of wiring the MCP3008. I'm going to show you how to wire it up for hardware SPI, so that's a lot easier of a configuration process for the Raspberry Pi. So with all that said and done, let's go ahead. So moving some of this stuff to the side, let's focus here on this half-size breadboard. So I've already went ahead and put some of these flat jumper cables in. The MCP3008, the orientation is very important. So if you see here, there's a little dot, so that should be on the top. The VDD, I believe, is this top pin on the right, should be hooked up to 3.3 volts. So I've essentially bridged this pin here to the positive rail, and then also the VREF is also on a 3.3, so it's on this positive rail. And as for the grounds include the AG and D, so that's bridged to the negative, and then for the other ground, which is a D, G, and D, which is this bottommost pin, is also bridged to the negative rail. So now we're going to need 4 GPIO connections to be made. So I'm going to just rip off 4 of these right here and just attach them in a linear fashion. So there'll be 4 ports available. So just go ahead and plug those in. So now that that's done, we just need to make the appropriate connections on the Pi. So the topmost pin is the SCLK, and oh no, I apologize. So this yellow jumper cable is connected to the CLK, and that goes to the SCLK pin on the Pi, which is the 9th on the bottom row. So let me go ahead and count that. 1, 2, 3, 4, 5, 6, 7, 8, 9. And then continuing on, we need D out, which is the green pin, or the green jumper cable, and that's connected to the MISO pin on the Pi, which is right next to the yellow pin. I apologize for this slow process. I'm sort of reading off this manual here. Okay. So now that we got the clock D out, we need DN. So of course DN is the blue cable in my case, which is the 3rd going down, and that's hooked up to up to MOSI, which is right next to the green pin, obviously. And finally, we're left with the CSHS/SHDN, which is the bottommost purple pin, and that's hooked up to CE01. So CE01 is right across from this yellow pin. And there we go, that's pretty much done. So yeah, I apologize if this is hard to follow. There will be a schematic on the website that should clearly lay it out for you. So now that we've hooked all the necessary connections to the MCP3008, we need to go ahead and get 3 more jumper cables. So I'm just gonna pick 3 random ones. Oh, this is good right here. So I have a red, brown, and black cable. So the red cable, this is gonna go to the positive rail, which will be 3.3 volts, and then the ground will go to the negative rail. So this red cable goes to 3.3 volts, and then black cable goes to any available ground. So let's just do 1, 2, 3. Third pin from the top, so that's ground, and then this will be our signal cable. So as you can see, we've plugged everything up on this right side. So these are the available channels. I believe there's, how many? Yeah, there's 8 available. So we're gonna start at 0, which is the topmost, and then plug that in. Right. So I made an error. We're actually gonna need 2 more jumper cables. So we're gonna need to supply the sensor with power. So we're gonna need to hook into this positive and negative rail right here. So I'm gonna just go ahead and do that. So now, actually let me flip that around so it makes more sense. So red will be positive all around. Sometimes these holes are, there we go. So looking at this touch sensor, we can see that it has a ground, Vcc, and signal. So ground obviously is the orange cable here, so that goes to the negative rail. Vcc, we supply the 3.3 volts, and the signal cable in this case is brown, so this goes to signal. So this is sort of the process that you're going to go through to hook up an analog sensor. So in this case it's a capacitive touch sensor, but if you had another sensor, this is essentially where the only change would happen right here. Of course, that's not the case for all sensors, but for the most part. So now that that's done, we're gonna go ahead and head over to the Linux terminal to activate the SPI interface and also download the MCP3008 library, and then we're gonna go ahead and run some test scripts and a sample script for the capacitive touch sensor. Okay, so I jumped over to my other computer and I've essentially fired up a browser here,
and I'm looking at the Adafruit tutorial for the MCP3008. This is sort of the guide that I'm following. If you ever run into issues, I highly recommend you take a look at this guide. There'll be a link in the description below. So as you can see here, it sort of walks us through the process, the two different pinout setups. So we're going through the hardware SPI setup currently. So let's go ahead and fire up a SSH terminal and log into the Pi. The first thing that you're going to need to do is sudo raspi-config, and you're going to need to go down to interfacing options and go to SPI and make sure that it's enabled. Yes, okay, and then just finish. So now that that's done, we're gonna need to go ahead and essentially check to see if SPI is enabled. So I believe the command is lsmod. Yeah, so lsmod, we can see that SPI underscore BCM2835 is present, so I believe that's an indicator that SPI has been enabled. There's also several other ways to check, but that's sort of a quick check. So now we're going to go ahead and install the Git project, the Adafruit Git project for the MCP3008. So go ahead and do a git clone. I'm also assuming that your current Raspbian is up to date, so I don't know if you've already have, but go ahead and do a sudo apt-get update. If you haven't, make sure you go ahead and do that. If you ever run into problems or dependency issues, double check the Adafruit site that I mentioned previously. So now that we've cloned the Git project, let's navigate to the new directory. So cd, go ahead and install sudo python setup pi install. I already installed it, so you'll probably see different output. Okay, in this case it was successful. Now we can do an ls to see more of the contents within this directory, and let's navigate to the examples subfolder. There we're presented with two different Python scripts, so go ahead and use any editor, text editor that you want. We're gonna have to make a couple changes. So here in simple tests, by default, the hardware portion is commented out. So go ahead and comment the SPI configuration part. So anything like the CLK down to MCP, go ahead and comment that out, and then uncomment everything under this hardware line here. So SPI port to MCP, make sure that's uncommented. Go ahead and save that. Double check differential.py and make sure that's the same case here. Go ahead and comment out all at the software SPI portion and uncomment the hardware portion. Okay, so now that I've made the changes to the script, I'm going to go ahead and run the test script. So I'm going to do python simple test.py. I'm going to hit run, and then I'm going to go ahead and touch the capacitive sensor, and you should see some changes to the 0 channel. So I'm going to go ahead and do that. You can see here the 0 channel is where we hooked up our capacitive sensor. So when I wasn't touching it, you could see that it was all zeros, and then right here when I touched the sensor, it was essentially a binary result, and the value changed to 1023. So now we know that the analog to digital converter is set up correctly. And the final script that I made was more in line with the capacitive touch sensor. So in this case, every time we touch the sensor, it'll register like a touch event happened, and there'll be a timeout, so that way it doesn't constantly like print to the screen that message. So I'm gonna go ahead and run this Python touch.py script. So again, I'm gonna go and run the script and then touch the sensor, and you should see the output. So there you go, guys. You can see that every time I touched it, it printed out this message, touch detected, and that's essentially how you interact with the analog to digital converter on the Raspberry Pi. Stay tuned for upcoming content. I'll be going through some of the more interesting sensors that don't natively work with the Pi unless you have this sort of conversion setup. And I hope you leave a like and subscribe. Comment down below if you have any problems. I'll try and answer to the best of my ability. And peace.